Scientific notation is a way to write very large numbers or very small numbers in a more efficient way. The examples we'll be looking at aren't necessarily going to be those biggest or smallest numbers, but we're going to look at the process for writing something in scientific notation and converting scientific notation back to standard notation. Okay. There are two elements to scientific notation. There's the coefficients and there's a power of 10. Power of 10. Okay. So the coefficient must be between 1 and 10. Between 1 and 10. And our power of 10. Okay. If the exponents is positive, that means it is a large number. If the exponent is negative, that means it is a small number. Okay, so we have large numbers and we have small numbers, something between 1 and 10. Okay, let's define what is and what is not a large number. Okay, large number is greater than 10, or is 10 or greater, or the small number is between 1 and 0. It's between, I'll say 0 and 1. Between 0 and 1. So let's identify if something is in scientific notation or not. Okay. And so we have 4.7 times 10 to the 6th power. Okay. See, our coefficients, 4.7 is between 1 and 10. We do have a power of 10, so yes, this is in scientific notation. So with another example, let's say we have 8.4 is 11 to the negative 5th power. Okay. The situation, we have a coefficient between 1 and 10, but our power is not of 10. Okay. It's of 11 instead. Okay. So it should be a power 10. Let's take a look at 18.5 times 10 to the negative 2nd. We have a power of 10, unlike last time, but it's our coefficient. Coefficient must be between 1 and 10. Okay. We've seen what it looks like. We see two ways that is not scientific notation. So let's talk about converting a number into scientific notation and back. All right. We know what a large or small number is. So let's take a look at if we have 529,000. Okay, 529,000. Okay, here's what we know. We know that this number is large. Okay, so that means it's going to have a power, an exponent that is positive. So how do we convert this into scientific notation? Our first step is we move the decimal. Move decimal after first digit, really first non-zero digit. We'll see why I specified non-zero here in just a moment, okay? But if we work from left to right, we see that our first digit, if not 0, is 5, between 5 and 2, right? So second thing we do is we count the places it moves. Count the places the decimal moved. Okay. And this situation, the decimal starts at the end and moved 1, 2, 3, 4, 5 places from the end. Okay. We're gonna hold on to that 5 for just a second. I'll put it in a box actually. Worst box ever. Okay. So we rewrite coefficients. Rewrite the coefficient. 5.29. We do not need to keep the zeros. Rewrite the coefficients. And last step, power of 10. Excuse me. The exponents on the 10 is the number from step 2. So in this case, we'll multiply by 10 to the power of 5. 10 to the power of 5. Okay. Pretty straightforward. Let's take a look at a small number. Let's say we have 0.0000814. Okay, this is a small number, so we know we're gonna have a negative exponent. Let's move the decimal after the first non-zero digit. So again, working from left to right, our first non-zero digit is after 8. Okay. How many places do we move it? 1, 2, 3, 4, 5. Okay, so we're gonna keep that off to the side. It's a little bit of a better box. Let's write this coefficient, 8.14. And we go, it's gonna be times 10 to the number from the second step. But remember, a small number has a negative exponent. So in this case, it's going to be 10 to the negative 5th power. 10 to the negative 5th power. Okay. We're now going to go over how to go from scientific notation to standard form. Okay. Let's say we have 6.85 times 10 to the 6th power. It's 10 to the 6th power. Okay. Well, we know this is a large number. Okay. So the first thing we want to do is identify if it's large or small. Okay. Large or small. In this case, we know it's large because it has a positive exponent. Okay. So step 2 is move the decimal the number of the exponent. Okay. Number of the exponent. Big thing I want us to focus on is understanding that this is a large number. So we know that if it's a large number, we need to move the decimal that makes this number bigger, not in a direction that makes it smaller. So if we have 685 and the decimal was here, move it 1, 2, 3, 4, 5, 6. Okay. Move the decimal in accordance to where on what the exponent is. Final step is fill in blanks with 0. Okay. So 1, 2, 3, 4 zeros. Our final answer is 6,850,000. Okay. So you look at one more example. Let's see, we have 1.29 times 10 to the negative 4th power. Okay. Well, we know this is small because it's a negative exponent. So we 129. Sorry, we need to move that decimal. 1, 2, 3, 4. Okay, that's where our decimal place is now. When we moved it, in this direction because we need to make this a small number. Fill in the bunch of zeros. Our final answer is 0.000129.